For question 1, using suitable method, find the particular solution to the differential equation d square y over dx square plus 3 dy over dx minus 4y equals to 10e to the power of x minus 250 cos 3x that satisfies the initial condition y0 equals to 13 and dy over dx equals to negative 30 when x is 0. From the question, we will do characteristic equation r square plus 3r minus 4 equals to 0, where we can use equation and we get r1 equals to 1 while r2 equals to negative 4, which is different root, and we use the y equals to a e r to the power r1x plus b e to the power r2x, and we get yc equals to a e to the power of x plus b e to the power of negative 4x. And then we from the question also we get fx equal to 10e to the power of x minus 250 cos 3x. For the first 10 to the power 10e to the power of x, we give into yp1, while negative 250 cos 3x we give to yp2. For yp1, fx equal to 10e to the power of x, it will get into general solution yp1 equals to x to the power of r ke to the power of x. And if we put r equals to 0, we get yp1 equals to ke to the power of x. And then we compare between yp1 and yc, it's get same. Then we cannot use r0 and we proceed with r1. We substitute and we get x to the power x ke to the power of x, and then we compare yp1 with yc, and it's not same, and we can proceed with yp1 equals to x ke to the power of x. Next, for yp2, the fx is negative 250 cos 3x. We get the general solution, it's xr bracket m cos 3x plus l sin 3x close bracket. If we put r to the 0, we get m cos 3x plus l sin 3x. We compare yp2 with yc, and then we get m cos 3x, and it's not same, and we can proceed with yp2 equals to m cos 3x plus l sin 3x. And then we combine it back, and we get yp equals to x ke to the power of x plus m cos 3x plus l sin 3x. And then we proceed with finding yp prime and yp double prime. For yp prime, we get x ke to the power of x plus ke to the power of x when we use the product rule here. And for the m, 3m cos 3x and l sin 3x, we differentiate and we get negative 3m sin 3x plus 3l cos 3x. For the next equation, when we do second derivative, we get x ke to the power of x plus k e to the power of x plus k e to the power of x minus 9m cos 3x minus 9l sin 3x, where here we use the product rule again, and when you derive k e to the power of x, it gets the same, and then we get x k e to the power of x plus 2k e to the power of x minus 9m cos 3x minus 9l sin 3x. And then we put the yp prime, yp double prime and y into main DE, which is y double prime plus 3y prime minus 4y equals to 10 e to the power of x minus 250 cos 3x. And then we get 5k e to the power of x minus 13m cos 3x minus 13l sin 3x minus 9m sin 3x plus 9l cos 3x equals to 10 e to the power of x minus 250 cos 3x. And then we do the equation. We put in the same variable, where first we put it in e to the power of x. We get 5k equals to 10 and we get k equals to 2. And then we put in same variable cos 3x. We get negative 13m plus 9l equals to negative 250 for first equation. And then for sin 3x, we get negative 13m plus 9l equals to 0. We do the simultaneous equation and we get L equals to negative 9, M equals to 13. For YP, and then we put the K, L, M, N into the YP equation and we get 2x e to the power of x plus 13 cos 3x minus 9 sin 3x, and we put in the equation where y equals to yc plus yp from the general equation, and we get a e to the power of x plus b e to the power of negative 4x plus 2x e to the power of x plus 13 cos 3x minus 9 sin 3x. From the question, y0 equals to 13, we substitute and we get a plus b equals to 0. And then we do the first derivative. We get a e to the power of x minus 4b e to the power of negative 4x plus 2x e to the power of x plus 2 e to the power of x minus 39 c 3x minus 27 cos 3x, and then we substitute with y prime 0 equals to negative 13 and we get a equals to 4b minus 4 minus 5 for second equation. We do the simultaneous equation and we get b equals to 1, a equals to negative 1, and we put in the main differential equation and we get y equals to negative e to the power of x plus e to the power of negative 4x plus 2x e to the power of x plus 13 cos 3x minus 9 sin 3.
Okay, I will explain how I get the answer for the question 4. Okay, first of all, when we get the question, we have to find the root of this question. For this equation, we have the same root, which is 1. First root is 1 and second root is also 1. So we have to use a generic equation, which is for the same root. Okay, then we got here is c1 plus c2x multiplied by e power of x multiplied by 1. So we use now we have a fx equal to 6 multiplied by e power of x, and we sub the value of r equal to 0 in the equation of yp, and we get k multiplied by e power of x. So when we get that, we compare between the yc and also yp by and substitute r equal to 1 and r equal to 2. So after we get the equations, we need to differentiate the equation, first differentiate and second differentiation. For the first differentiate, we use it such a first equation, and for the second differentiate, we use it such as a second equation. So when we differentiate this equation, we using a power rules. So when we get the first equation and second equation, we have to substitute it in one to the two equation. So after we substitute, we use a product rules, and we use the equation y equal to yc plus the yp. So we have a yc and we also have a yp. So based on the equation given, at the x equal to 0 and y equal to 0, we just substitute the value into the equation that we get. And for the second, we use in the equation is also state x equal to 0 and second derivative is equal to 2. So we sub it into our equation, and in this process we also use a product rules. So we will get c1 equal to the 0 and c2 equal to the 2. So after we get the c1 and c2, so we can back to the equation and put the value of the c1 and c2 in the equation. So for the final answer, we get y equal to e power of x multiplied by 3x power of 2 plus 2x.